Hello everyone. Today our topic is focusing on IGCSE physics regarding motion. Without further ado, let's get started. Scalar is a quantity that has only magnitude, numerical value, but no direction. Example scalar will be distance, speed, and temperature. And you can see a second example. Example, you are working, speed is 5 kilometers per hour, and this is a scalar quantity because it only has magnitude and no direction. Vectors. Vectors are quantities that has both, which is magnitude, numerical value, and direction. Example, vectors are displacement, velocity, force, and acceleration. Example 2 is a man pushing a trolley full of groceries items, and the man is applying a force to push a trolley, and this force is represented as a vector with both magnitude and direction. Kinematics. Kinematics is a branch of physics that deals with motion of objects without considering the underlying causes, which is forces, that lead to that motion itself, which is including concepts such as position, velocity, acceleration, time, and displacement. What is position? Position is described the location of an object in space that relates relative to a chosen reference point. Displacement is a measures the change in position, taking into the account both direction and distance. Velocity refers to the rate of change of position over time, include both magnitude and direction, and the standard international unit is meter per second. The formula for velocity is SF referring to final displacement in this context, SI referring to initial displacement, V refer to velocity, T refer to time per second, and the formula for V, which is velocity, is equal to final displacement minus initial displacement divided by time. And to get you the amount for average velocity is total displacement divided by total time taken. Before I go further, let's look into displacement formula. Displacement formula will be final position minus initial position. What is speed? Speed is the magnitude of velocity, indicating how fast an object is moving without considering direction. SI unit is meter per second. Let's look into speed formula. dF refer to final distance in meter. Di refer to initial distance also in meters. V is actually the speed. T is a time per second. To get the formula for speed, you get the value of dF, which is final distance minus initial distance divided by time per second. To get the average of speed, you have the total distance divided by total time taken. Acceleration. Acceleration measures the rate of change of velocity. Like velocity, it includes both magnitude and direction. SI unit of acceleration is meter per second. So A, for the formula A is referring to acceleration, which is meter per second. T is referring to time, which is in second. V is referring to final velocity, which is meter per second. And U is referring to initial velocity, which is meter per second. So, to get the actual value of acceleration is V, which is final velocity, minus U divided by T. And the time is served as a parameter to track how motion changes over a period. A graphical analysis of motion, which is a distant time graph, can be divided into three types of kinematic graph. One is a distance versus time, speed versus time, and acceleration versus time. In this graph, we have a distance versus time, which is described about the gradient represents speed. And distance is scalar quantity, which is it will never become negative. If you can see, the value distance is positive and the times is also increasing with a positive value. And if the object does not move the distance from the reference point, does not change. So if you can see, this is a steady speed. After sometimes at 4 seconds, the speed is about slanting. And it becomes no change at all, stagnant. And now the steady speed return to the start. And if the object does not move, the distance from the reference point does not change, represented by the straight line. Graphical analysis of motion, which is distance versus time, where the object moving at constant speed will have a straight line, diagonal line, and the slope of line is the speed. How to calculate the slope? To calculate the gradient, we need to draw a right angle triangle of any size below the diagonal line and use the following formula. The slope equals to rise divided by run, which is y divided by x equals to m. We use this y equals to mx plus b. B is actually the intercept, where you get y equals to mx, and is the value of, after you divided this value, you get the value of mx plus b. X is the value of x, where you get the actual x. Let's say you want to find this slope at this location. So you have to use this formula, y equals to mx plus b. Next, graphical analysis of motion. A constant acceleration will create a curved line as shown in the diagram left side. So the slope of the diagonal line drawn at any given point is the speed at that instant. Speed time over time, or speed versus time graph. You can see this is a speed and this is the value of A, B, X and Y, and this is the C value. The gradient represents the acceleration or retardation. Deceleration and speed is a scalar quantity. It will never become negative. The graph starts at a specific point at the origin, which is 0, on the velocity axis, indicating the initial velocity of the object. The A is horizontal line, which is OA, indicate that the gradient of the slope is constant. and thus acceleration or deceleration of the object remain the same for the part of the journey until times x. You can see from this diagram, as the object is moving from A to B, its speed remains constant due to the gradient is 0 until time y is taken. From B to C, the object is experiencing a constant retardation due to decreasing slope with a fixed gradient. And in summary, a speed time graph for acceleration usually represents how an object's velocity changes with the time due to acceleration. And it provides valuable information about the object's initial velocity, the magnitude, direction of acceleration, and a resulting change in velocity over time. Kinematic equations. Kinematic equations are the alternative methods used to calculate various unknown during motion. Four equations are depending and workable on one important assumption, that the acceleration of the object should be held constant throughout entire journey. Let's look into equation 1, how we derive to equation 5. Okay, starting with the formula for the velocity. We get an A equals to V minus U divided by T. And you simplify V equals to U plus AT. From this equation, you can derive equation number 2. V equals to U plus AT. And we get the value of T equals to V minus U divided by A. And then from this velocity step or formula, you can get step 3, which is S equals to half of U plus V and times T. And from this step, you can substitute equations 1 into equation 3, you get this figure, this formula, S equals to UT plus half AT to the power of 2. And next, for the step 5, by substituting equations 2 into equation 3, you get V to the power of 2 equals to U to the power of 2 plus 2 AS. Accelerations of free force. Weight is the only force acting upon it. Acceleration of free falls is the uniform acceleration of a body under the influence of gravity force. Acceleration of free falls is always constant near the surface of the Earth. 9.81 meter per second, rounded to 10 meter per second. And in case of air resistance, the value decreases due to the opposing force in the opposite directions. And in the absence of any other forces, gravity acts on each part of the body equally, and this is similar to weightlessness. Let's look into terminal velocity, where we have speed versus times. This is the call it accelerates. When the value is constant, we call it terminal velocity. And this is the position where parachute is open. And when the position or the situation becomes decelerate, and this is called terminal velocity. Okay. When a body falls from a particular height, it will experience an air resistance opposing force which is directly proportional to its speeds. So as a conclusion, increasing speed, the acceleration of that body will decrease gradually. The air resistance will have the same magnitude as weight of that body causes to be 0. The body will experience a constant velocity that is named terminal velocity. What factors that affect the terminal velocity weight, size, and shape? First, an object with high density but a small surface area will experience a high terminal velocity because it has to travel longer distance before its weights equal the opposing air resistance. Number two, an object with low density but a large surface area will experience a low terminal velocity because it has to travel shorter distance before its weights equal the opposing air resistance. With that being said, I would like to end my presentation. Please subscribe to Jones Nabila YouTube channel, and there will be a customized notes at beacons.ai/Jones Nabila, or you can access Jones Nabila Instagram. Thank you very much for listening. Hope you are doing very well in your studies. That's all for today's presentation. Hope to see you in the next presentation.